Welcome guys to another session on dynamic programming, and today we're talking about sequence alignment with delta scoring matrix. So let's dive into the problem. We are given two sequences X and Y which look like genome sequences. They have alphabet over A, C, G, and T. The scoring matrix delta M comma N is given where M and R are alphabets using that same A, C, G, and T, and there may also be a possibility of a gap as an alphabet. So we have to find the highest score alignment between these two, and we have to find it in order mn time. So here's a setup of the matrix. You write down one sequence on the y-axis and one sequence on the x-axis, and you introduce a gap as the first character on both sides. And you start at the gap. Now, I have written this as a 0, but the scoring matrix delta may also have a dash dash in it, and if it is, you can start with delta dash dash here, or you can start with a 0. I think it's probably okay to start with dash dash as 0. So we start there, and then the most initial thing is to fill this row and this first column. And this is pretty straightforward, that when you walk along this line, the only possibility is you go this way. Um, you cannot go upwards and you cannot go backwards, right? So you only go this way. And so the possibilities, if you go this way, this side remains a dash, so you introduce a dash and a C, and then you add this to this and it becomes a dash and a C plus a dash and a T, and you keep walking, and the next one will be this plus a dash and a T, and then you move to this and it'll be a dash and a G, and the next one will be this plus a dash and an A. And when you walk in this direction, similar thing holds. When you come here, it'll be a T and a dash, and this one will be T and dash plus C and a dash, and it'll be this plus a C and a dash, and then this will be an A and a dash. So you just keep adding these extra scores on top of the previous score as you walk along this line. So now that we have set up the first row and the first column, let's look at how we compute the first real element here, which is different from the first columns and the first row. So here there's three possibilities. One is you can take both the characters. You can take the T and a C. And in this case, T and C happen to be a mismatch, but it was possible that when you go down this red path, there could be a match. It could be a T and a T or a C and a C. It's possible, right? So when you go down this path, it means that you're taking both characters. And when you write them down, it's basically this score plus delta T and C, right? So that's would be the score as you go along this path. And then you can come along this path, which would be delta T and a dash was this one. And so when you take T and a dash and um, you sum a dash and a C, because this path movement would be, you did not choose a new character, so it'd be a dash here, and you took a C here, so it'd be a dash and a C, which you see here. So this sum would be the other one. Now, when you come from this path, it'd be a delta dash and a C, which is already there. And this would be what? This would be a T and a dash. And you see a T and a dash right there. So those are the three options by which you can arrive here. And you have to pick the max of all these three options and then put that here. So whatever is the max of these three options, that goes here. And now that you know how to fill one square, remaining is just really keep on adding that. And then finally, when you get to this last point here, this is your score, or max alignment score for this sequence. So this, by the way we did it took order mn space and order mn time. But really, as we have seen in the previous polynomial sequence alignment problems, which I believe was 6.24, we saw, and you can go back and look at the 6.24, that you really don't need to store this whole space. You could reduce this by keeping an order n time, order n space, and you only keep two columns, and that's all you need to compute this score, right? So, and if the only thing you needed is a score computation here, then you can do this in order n space, but you still need order m in time, because to compute the whole score here, the final score, you have to compute over all possible options. So it takes order m in time, especially because each computation is constant time, because it's only 3 here. So this whole thing can be done in 3m in time, or which is order m in time, and therefore The overall complexity is order mn. So that's it, guys. This is the solution to this problem, and hopefully you liked and enjoyed it. And if you did, give me a thumbs up and do subscribe to my channel if you enjoy dynamic programming. I will bring you more dynamic programming solutions in time to come, and please do come back here and look for them. And until next time, take care and bye bye.